Of course, for this I wouldn't recommend the plastic, this is just experimenting, but if I remember correctly, PPS is fire retardant by default. Hello, welcome to my tech farm. Filament sent me PPS filament for the testing, and I got these products for free, but there is no additional payment from their side. But this video and actually the whole channel is sponsored by Polymaker. This is 5899BK, and from the datasheet I can see that this is a Lovocom 3F PPS-CF filament. Polyfilamide sulfide, if I remember correctly, and this is one of the most chemical resistant consumer filament on the market currently. And usually I print this filament on the engineering plate with the glue, but I noticed that this newest engineering plate for H2 printers are not so good. And I have better luck with the smooth PI sheet, but also with the glue. But they also sent me their build plate, and they told me that I can use this 90 degrees Celsius temperature, and I don't have to use the glue. So my May printings will be using this build plate. If you are not familiar, PPS-CF is, I think, the second strongest filament I can print on my printers immediately after PPS-CF, but it has its own advantages. I think one of them is temperature resistance and also smaller creeping. I want to test this in one separate video. The print temperatures are higher. This means that most of the printers which can reach 300 degrees Celsius are not enough. In this case, they recommend between 310 and 320 degrees Celsius, while usually are printed on higher temperatures, on the bed 90 degrees Celsius using their own build plate and 65 degrees Celsius chamber temperature. They mention drying settings, 90 degrees Celsius for 24 hours. Probably I will dry it a little bit in the HT AMS, but that's 85 degrees Celsius. It should be enough. So this is that build plate, and they mention it is thicker than regular, so don't flex it too much and clean it only with isopropyl alcohol. And the surface reminds me on plus a satin sheet, only of course in different color. And it is good for many other filament types too, without using the glue. Let's unbox the filament. Nice vacuum packaging, and the bag looks like resealable on the longer side. See, somebody can do it. End of the filament is glued, maybe it is brittle, but let's check that. Wow, the filament is very rigid and it started with unrolling, so be careful. Let's see how brittle is the filament. Okay, let's measure this. Start angle 20 degrees. Around 65, yes, very brittle filament. I'm quite sure it would break in many printers like H2S, Q2, K1 Max and similar, but H2D should be fine. Few words about the spool. This is how I like to lock end of the filament where the material is so brittle I cannot reuse the holes. Don't forget that this must be at least from the ABS if you want to dry this filament. On the sticker, very minimal information, basically only the material type and that's it. And I don't really like these plastic closed spools. It is not so good for the drying because the moisture will stick inside. I like better some temperature resistant spools with a lot of holes. Not sure if it's visible on the camera, I can see it is properly made from the polycarbonate. This means the temperature resistance is up to maybe even 120 degrees Celsius. I'm not sure why they dry it on the 90 degrees Celsius, but definitely some holes on the side would be very welcome. PPS drying settings in the MSHT, 85 degrees Celsius, but only 12 hours. It should be enough. This is out of the box spool. Drying is finished. I'm using external spool holder and of course a new print sheet from the 3D mat. There is no QR code, so I'm disabling the build plate detection. First a quick test. Layer adhesion test objects printed with 3 walls and 0% infill, and very important, printed by object. So far looks nice. This bed is completely new to me. Here it is finishing the first object and moving to the second one, and I'm changing the temperature to 325 degrees, and this is the third object moving to 340 degrees. It's finished few seconds ago. Bed adhesion check. Okay. I have to wait until it cools down without glue. The bed is 50 degrees Celsius. Okay, now it's removable. Oh. Maybe you don't hear it, but it has that metallic sound. Well, actually each of them looks really nice. These overhangs came out perfectly. So I'll check the layer adhesion and then I will decide which temperature to use. Can you hear it? Like coins. Usually I don't do this at night, but I want to continue with the printing and I need this information. And now the graph, even on 340 I can see some minimal increasing of the layer adhesion, but I don't like to go much higher than the recommend, so I will print everything on 330 degrees. My regular test objects, generic PPS-CF is the style profile, 65 chamber temperature, 90 on the bed, 330 nozzle temperature, and the maximum flow 5, cooling between 0 and 30%, and this 2-second minimal layer printing time is too short, and total printing time will be a little bit above 2.5 hours. The start is good, and this black color looks great on this green surface. It is so refreshing. The printing is at 42% and it will be finished overnight without my supervision. Good morning. The bed completely cooled down. But I will need some flexing. But yes, completely removable. And as always with the PPS videos, a bell. And look how small is this contact surface. But I trust to this build plate. The surface looks fantastic. Those carbon fibers completely hide the layer lines. Corner bracket plates, and this only represent the PPS material because I'm preparing a comparison video 3D printed versus metallic plates. Looks nice, even the top surface, so no over extrusion and the filament is dried. A corner bracket for 2020 alloy extrusion. I'm preparing a PPS-CF comparison video too, and this filament will be included. And I want to repeat the same test like with the PET-CF filament. On these corner brackets, this bridging is always critical. It's not perfect, but very acceptable. And rest of the test objects for PPS-CF comparison video. Okay, who can recognize what is this and why it is important to be from temperature resistant material? And do you know now? This is the second half. It's a small spool adapter. This one is from PETG, and this can be dried on any temperature now. This is my soldering iron and I don't have the rest for it, and I'm very curious if PPS-CF will survive these temperatures. I can see from color transition that here we have much higher temperatures and here there is no color change, and maybe if I use only this area as a support then it should be fine, just for curiosity. Let's measure the temperatures. Looks like it will be around 150 degrees Celsius. Almost a topic for a separate video, how much I can increase the printing speed or the flow rate, because almost 1 hour for this relatively small part is a little bit too much. With the PETG it will be printed in almost half hours. It nicely locks into the position, but let's see if it can survive the heat. It's on the set temperature. After 5 minutes, still in perfect shape, but I have to clean the tip. Okay, good to know. First experience after the printing, it was super easy, especially thanks to that build plate. I don't even have to use the glue. Earlier sometimes I had the problems until I was experimenting with different build plates. Only thing I would like to increase the speed, maybe a subject for the separate video, how much I can increase the temperature, because I still have a little bit space and the speed with this. I finished all the testing and I forgot to measure the shrinking, but I still have those objects for the separate PPS-CF comparison video. The design length of this one is 77 millimeters, and I am measuring about the elephant foot, 76.92 millimeters, so very accurate, very minimal shrinking. Tensile test horizontal printed objects. Well, for comparison, I will use the average PPS-CF, but I have only 4 in that summary table for my pattern supporters, and actually one of them is a glass fiber reinforced, but this is what I have, so let's see the numbers. Actually, this number is not bad to the average filament type, but compared to the average PPS-CF, this is very weak. And actually, I checked the datasheet, I was expecting something similar, so that's why I reprinted everything on the GDQ2, using almost the same parameters, and I got very similar number. And now layer adhesion, vertically printed. My rating for this size of the test object, and according to the table, this PPS-CF have a great, almost fantastic layer adhesion, much bigger compared to the average PPS-CF. Shear test side by side, horizontal and vertical. Printed in horizontal position, a little bit weaker compared to the average PPS-CF. Printed in vertical position, where the layer adhesion is important, a little bit bigger compared to the average PPS-CF, but in both cases this is not significant difference. Torsion test horizontally printed. 2.0. And now vertically printed. 1.8. The break on horizontal objects is very similar to break on vertical objects by other filaments. Of course, this one on higher load. First of all, it is very rare that I cannot do 90-degree rotation with horizontal printed objects, so I can present here only the maximal load, which is bigger compared to the average PPS-CF, and printed vertically, where the layer adhesion is again more important, it is again stronger compared to the average PPS-CF. I'm searching for that bending test object, and this metallic sound always impressed me. 3-point bending test on my universal testing machine, and this time this is not speed up video. The graph falls in function of time or deformation and other results. In this test I don't have even one PPS-CF filament, so I will compare it to the average PC-CF, and I have 8 pieces in the summary table, and we can see both bending strength and elastic modulus, so this PPS-CF is very strong. Another 3-point bending test. Distance between supports is 50 millimeters, and I am placing these loads one by one every 1 minute, and I am measuring the deformation after 1, 30 and 60 seconds. Currently this is under 10 kilograms, and usually I end the test here, but this is additional 1 minute, and you can see absolutely no changes. And visually no permanent deformation after this test. We can see very similar deformation compared to the average PPS, except here under 10 kilograms. But what was important for me, just for curiosity, I extended that test under 10 kilograms with 1 minute, and basically you can see absolutely no changes during that additional 1 minute. Impact test, this is Izod standard. Very brittle and almost sounds like some porcelain vase. One more time. And now Charpy. One more time in full speed. And results for 3 measurings, but let's see them on the graph. For the Charpy test I have only one in that summary table, so let's analyze the Izod. We can see that this tested PPS-CF is more brittle compared to average PPS-CF. It is brittle almost like average PETG, and even from the sound I can hear that it is more metallic compared to other average PPS-CF filaments. Grip test the deformation under constant load of 1.25 kilograms, which probably will be very small. Not so small as I thought. 13.20. And now let's jump in the time. Last day of measuring, visually no changes, but let's measure it. 13.24. Same like at the beginning. On this graph we can see the distance between two reference surfaces, and we can see bigger deformation on this tested PPS compared to the average PPS-CF, but the creeping is the difference between 2 days, and that's presented on the second graph, and we can see it jumping up and down a little bit, but this is just inaccuracy in measuring. This creeping is extremely minimal compared to almost any other filament type. Well, there is no temperature test in this video because the maximum of my equipment is not enough for this material, but in my future PPS-CF comparison video, I will use a soldering iron, I will push it with a known force, and I will measure the penetration after 30 seconds. Our results one more time: creep test, tensile test and layer adhesion, shear test horizontal and vertical, bending test deformation after 30 seconds, bending test deformation under these loads after 1, 30 and 60 seconds, torsion test horizontal and vertical, impact test Izod and Charpy, bending test distance between supports is 64 mm. I have the feeling that printing with PPS is just easier now. Well, yes, of course, thanks to high temperature, enclosed printers, good filament dryers, but in this case, thanks to this build plate. I also tried with the polycarbonate filaments. I don't have to use the glue, and when it completely cools down, with just very minimal flexing, I can remove the objects. Where do I recommend PPS-CF filaments? Where you need a high temperature resistance, or your part will be under constant load, because it is very good against the creeping. I have the feeling that it is better than the PPA-CF, but I will test this in a separate video soon. And also I mentioned that I'm preparing a PPS-CF comparison video, very similar to that PC-CF comparison. And my Patreon supporters will decide if I have to extend the list. And you can follow me on the Patreon even for free. There is a limited access, but you can be involved in this kind of discussions. And about these filaments, if you have some other experience, fill us down in the comment section. And thank you for watching this video. And as always, happy printing!